Harini, you're absolutely right that vanilla RAG is seriously flawed. And I think it's flawed in the retrieval part, and it's typically flawed in the fact that you have to make a choice of what part of the corpus of the context you hand over to the LLM. So you resort to setting a top K, here's the number of chunks that I want to get back. And there's your first problem. And so you have to either do this over and over again, and then the vector itself might not be a sufficiently nuanced representation of the semantic meaning of the context. The vanilla RAG is I'm finding it just not very helpful. And so when I saw your presentation of, hey, let's represent it not as a vector, but represented as a tensor, that seemed exciting. What's the computational load of representing the data as a tensor rather than a vector?
What's a computational load? So to your point, the tensor itself is intelligent. It's beyond the semantic. It's not just saying, hey, bank and bank are similar. It's trying to say that the bank in the context of the user question and the bank in the context of this document are similar. And that from a computational standpoint, because vector is pre-built as a tensor database, the load is not heavy. But if you were to do it in a pinecone or a regular vector database, that's where the challenge is, because now you will have to break each of these patches as a separate vector and store them as separate rows.
It seems like the key to this presentation is the use of Vespa as a tensor database, as opposed to using vector databases for, I guess, storing interim data. Maybe tensor is the tensor objects are maybe more advanced, or kind of a next level thing.
But Vespa is open source. So there is an open source version, and there is a Slack channel where you can download, where if you end up downloading those, so yeah, you'll find, if you ask interesting questions, you'll get the CEO to respond.
Under the hood, BioCanvas ingests multimodal data and represents these diverse signals in a unified tensor space, mapping lab values, physician notes, and imaging features into a shared mathematical representation stored in the Vespa AI vector database. This enables users to run natural language queries, attach reference images, and conduct sophisticated hybrid searches. For example, a researcher could search for patients aged 25 to 45 with brain scans showing tumors of similar size, location, and disease progression. In doing so, BioCanvas reveals subtle and clinically meaningful overlaps across modalities that traditional field-based queries cannot capture.